Welcome to Fresh Thinking by Snowden Optiro. My name is Hamish Guthrie, Managing Consultant at Snowden Optiro. Today I am joined by Sarah de Vries, who is a Principal Consultant in our mining team in Australia. Sarah has over 15 years of experience in open pit and underground mining with a focus for the last 8 years in mine electrification. Welcome, Sarah.
Thank you, Hamish.
Now, Sarah, why are people talking about mining electrification?
Well, primarily, Hamish, they're talking about it for decarbonisation. So about 8% of the world's global carbon emissions come from mining, and 40 to 50% of that come from diesel haulage. So there's a really big imperative to try and reduce our diesel usage in underground mines. Secondly, there are quite a few cost and productivity benefits with electrification. Electricity is a much cheaper power source than diesel, and it's also more efficient. So diesel is about 30% efficient, whereas electricity is about 90% efficient. So there's a big energy savings there as well. And lastly, particularly for underground mines, there are some massive occupational health and safety benefits that come with removing diesel from the underground environment. The World Health Organization has decreed diesel particulate matter as a class 1 carcinogen. So there's a strong drive to reduce workers' exposure to that underground. There's also a whole heap of other things like diesel dramatically increases the temperature underground. It's very noisy and there's a lot of vibration associated with it. So by reducing our diesel equipment usage, we can improve the health outcomes for our workers underground.
No, interesting. But mine electrification has been around for a long time.
Yeah, a really long time, Hamish. So shaft hoisting is electric, crushing and conveying is electric, rail haulage underground is electric, Kirina trolley assist truck haulage, been around for 50 years, also electric, and even tethered electric loaders have been around for a long time. That's electric as well. Unfortunately, a lot of these electrification options, traditional electrification options, tend to lose that in the flexibility states when compared with diesel equipment. And that's why we're now looking at battery electric vehicles.
So how do battery electric vehicles fit in to the mine electrification scene?
Well, they're the newer technology and they have the advantage that they're not as capital intensive as a lot of those traditional electrification options. And they also help us maintain some of that flexibility that we're all very used to with diesel equipment in underground operations. Lithium-ion batteries are a very relatively new technology. The technology is improving all the time in terms of battery capacity and battery range. And the costs are also dropping rapidly. So it's becoming a really viable option for underground mines now.
So what battery electric vehicles, BEVs, are available on the market?
Pretty much everything for underground is available now. So if we look at our haulage options, loaders and trucks are both available from Epiroc and Sandvik, two very well-respected OEMs in the underground mining space. So Sandvik's largest truck at the moment is a 65-tonne truck, and that's equivalent to the largest diesel truck we use underground. Epiroc have a 42-tonne truck. In terms of loaders, both Sandvik and Epiroc have an 18-tonne loader. So not quite up to the 21-tonne loader stage that is available in diesel at the moment, but we're pretty close. So all of those haulage options are available off the shelf right now. The main limitation is the truck range. If you have a very deep decline mine, you may not be able to complete an entire haul cycle on one battery charge. But for loaders and shallower decline mines, it's a very viable option. In terms of your other equipment we use underground, drills are also available. Battery electric drills are also available from Sandvik and Epiroc. All your other ancillary gear is available from companies like Normet and McLean Engineering. And light vehicles is just exploding. So there's everything from battery electric conversions of Land Cruisers to battery electric vehicles specifically manufactured for underground, such as Coverterra and Rockion. And then there's, road-ready battery electric vehicles such as the Ford Lightning F-150 and the Rivian, which are now also going into the underground space.
And tell us more about how do you charge these vehicles?
Charging, that's the big problem. Not a problem, different to diesel. So you generally need to plug these batteries in to charge them. So for drills, it's not really a big deal. We already plug those drills into electric power to operate them. And the batteries, which are basically just used for tramming, are charged at the same time. It's the same with a lot of the ancillary equipment. They get plugged in to operate and they can also charge the battery. Light vehicles and some other ancillary equipment will need to be parked up probably over shift change or at crib time to charge those batteries. The big batteries obviously come in the haulage trucks and loaders. We don't really want to have to park those very critical pieces of production equipment up for too long. You would have to park them up for a couple of hours to fully charge those batteries. So both Epiroc and Sandvik have implemented battery swapping systems where you can just drive into your charging bay and swap your depleted battery out for a fully charged battery. So the interruption, while greater than filling a diesel tank back up, is not too long compared to parking it up and charging.
No, interesting. And tell us more about the electrical infrastructure that comes with BEVs.
So most underground mines already have a well-established electrical distribution network. We need power to run our fans, to run our jumbos, and so that electrical distribution is generally rolled out as the mine develops. So there's no big change there. We do need to put charging bays in, so that might require some extra development, and it also requires electrical infrastructure, the actual charging equipment itself. You may also need additional workshop facilities if you can't tram easily all the way to surface, and you'll obviously also need charging equipment in the workshop itself. So there is definitely an increase in the infrastructure required to support BEV fleets.
Are there any cost and productivity benefits? Sorry, I'll start again. Are there any cost and productivity benefits from implementing BEVs?
Absolutely. As I mentioned earlier, it's much cheaper to run electric equipment than diesel equipment, so you're saving all of that diesel expenditure. Unfortunately, BEVs at the moment are quite expensive from a capital cost point of view, so you're paying up to twice what you would pay for a similar piece of diesel equipment. Over the next 3 to 5 years, we expect those costs to come down substantially. However, even with those increased capital costs, we're expecting cheaper costs over the life of the piece of equipment because you're saving your diesel and you've got massive savings on your maintenance because electrical equipment is much simpler to maintain than diesel. We can also get productivity benefits as well. Electric equipment is much faster, particularly on the ramp. So I've heard of cases in Canada where battery electric truck fleets are achieving speed increases of about 50%. So that adds up to a significant amount of productivity improvement.
And what about occupational health and safety benefits?
This is the big one for me. I really think that this is the reason why anyone looking at designing a new mine, a new underground mine, should be looking at it. Diesel particulate matter is a Class 1 carcinogen. By removing diesel from the underground environment, we can reduce that exposure. We also can drop, so typically comparing a diesel loader with a battery electric loader, the diesel loader will increase the temperature by 3 to 4 degrees downstream from that loader, whereas the battery electric loader doesn't have any heat increase at all because it's not losing all that heat. So we're getting cooler working conditions, we're getting quieter working conditions, we're getting vibration-free working conditions, and all of those things add up to less fatigued workers and hopefully safer workers as well.
No, good. And tell us more about which mines are most suitable for electrification.
Hot mines is the number one. There's a mine in Canada that couldn't justify an expansion to a new ore body because of the amount of cooling they would require. However, when they replaced the diesel equipment with electric equipment, it actually made financial sense to go after that new ore body. So definitely hot mines are a prime candidate. new mines or an ore body extension, to really get the cost savings that you can get with primary and secondary ventilation reduction and cooling reduction, you need to design that mine from scratch. For example, you may be able to save on 1 or 2 ventilation raises, as well as fans, and as well as all the power operating requirements that come along with that. So if you're trying to retrofit an existing mine, you may not be able to get all of those benefits. So first prize would be to do it from scratch.
Well, electrification is a very interesting topic. Sarah, thank you for joining us on Fresh Thinking and for participating in this discussion about underground electrification. If you'd like to listen to more of our Fresh Thinking by Snowden Optiro podcasts, you will find them for free on our website, Spotify, and most other podcast platforms. If you enjoyed this podcast, please subscribe to our YouTube channel so we can keep you up to date with our technical podcasts.